Hello, Mr. Fries, Algebra 1. I'm looking at Unit 5, Homework 2. I believe this is going to be given today on the 8th. This is Monday and it's not due till Thursday, the 11th of March. Let me take a look at the odd ones for you. Go ahead and try the even ones. If you make mistakes, don't worry about it. Correct them, and that's called the process of learning right there. Okay. We're going to solve each system of equations by substitution and clearly identify our solutions. So I'm going to circle my solutions as I get moving on this. So if y equals this and y equals this, well, y would equal y, right? Because, identity, it's y is y. So these two are going to equal each other. So their solutions are going to equal each other. So when I set the solutions, or what they're equal to each other, I end up just getting my x's together and the constants together. I get negative 14 equals 2x. What I did was I subtracted 3x from both sides, and then I subtracted 33 from both sides. I divide both sides now by 2, and negative 14 divided by 2 is negative 7. I go back into one of the problems. It doesn't matter which problem you pick. You could pick either one of these and you're going to get the same answer. So I plug in that negative 7 and I did the first one. So I had 3 times negative 7 plus 19. So it ends up being negative 21 plus 19. Negative 21 plus 19 is negative 2, so that would be my y value. Number 3. This tells me that y equals this, so I'm going to take this and plug that in for y, so then I'm just dealing with x's, because when I'm just dealing with x's, then I could solve something. If I'm dealing with both x's and y's, I can't solve anything, But if I'm just dealing with x's alone, one variable at a time, I could solve it. That's why we're doing this substitution thing. So I combine my like terms, isolate the variable, and I get x equals negative 3. Okay, and how I did that is I subtracted 8 from both sides, divided both sides by 2. Okay, then I plug in that x value, which is negative 3. I plug it in for x. So negative 3 plus 8, negative 3 plus 8 gives me 5. So y equals 5. For number 5. And so these both are my solutions, negative 3 and 5. And he might have you write them like this, negative 3, 5, like that. As a point on a graph, because this is a point on the graph where these are going to be intersecting, okay? For number 5, if we were to graph these, this tells me what my y equals, so I'm going to substitute this in right there for that y right there, okay? So I plug that in there. I rewrite the equation. Instead of y there, I have what y equals, because the first one told me what y equaled in this problem. Okay, so I end up using the distributive property, 3x. 3 times 2 is 6, so that's how I got the 3x and the 6. Combine my like terms, isolate the variable. When I subtracted 6 from both sides, I got 0, and I have x equals 0. I plug 0 back into this problem. What does y equal? It equals 0 plus 2. 0 plus 2 is 2, so that's what y equals. Once again, you can write your like that in parentheses or whatever, 0, 2, circle it, whatever. You could just leave it the way I had it. That would be fine. Okay, working on number 7. Don't worry about what's in red yet. This tells me what y equals. So if I substitute this value in for y, I end up getting this. All right. Here's the problem. When I use the distributive property with this negative into parentheses, I end up with negative 2x and a minus 1. When I combine my like terms, 2x minus 2x, I'm done with my x's. They're gone. They disappear. And then when I add, I'm supposed to be adding a 1 to both sides. This should be 4. Sorry. I end up with 0 equals 4. It does not. Whenever you have something like that, that says like something weird like 0 equals 4. 0 does not equal 4. 0 equals 0. It's no solution, okay? And why is it no solution? In red, let me go back and take a look at this. Notice that this is in slope-intercept form, right? You have the slope here, slope of 2, and the y-intercept is 1. If I were to change this problem into slope-intercept form, I get it y equals 2x minus 3 in slope-intercept form. Notice they have the same slope, 2, the slope of 2. These two lines, but they have a different y-intercept, so this one's going to be below this line on a graph. They are parallel. Anything having the same slope is parallel. That means no solution. They're never going to cross, so it makes sense. If you happen to have, like if this was 4 here, 4 equals 4, if this canceled out somehow, I don't know, and you ended up with like two numbers that are equal to each other, that's infinite solutions. That would be the same exact problem. That would be if this number here, instead of minus 3, was a plus 1. So if when you move it around, it's exactly the same problem. Then you would get infinite solutions. You would get something like, 4 equals 4, or 0 equals 0, something like that. Okay, moving on. Number 9. I'm going to change this one to look like this so that I could use it and plug this in, substitute, I should be saying, because we're using substitution. Substitute this in for y so that I'm only dealing with x's. Now that I'm only dealing with x's, I can solve for x and I get x equals 3. I plug that 3 in for the x into one of the problems. I chose the second one to look the easiest. I always choose the one that seems to look the easiest to me. And then I end up with 12 plus y equals 6 or 8. And so 8 minus 12 is negative 4. So there you have it for number 9. For number 11, I change this so that I just have what y equals. Y equals negative 2x minus 2. I plug this value in for this y in this problem. So I go back, plug that in, right? Plug that in for that y. And I use the distributive property. That's how I got these. And then I combine my like terms. That's how I got this. And then I isolate the variable. That's how I got this and this. X equals 2. 2, I plug into one of the problems. I chose the first one. And I end up getting 4 plus y equals negative 2. I subtract 4 from both sides. I get y equals negative 6. For number 3, I changed this one. I just subtracted 8x from both sides. But then I noticed that this is a minus y. I don't want to know, or a negative y. I don't want to know what negative y equals. I want to know what regular y equals. So I took each term, as long as you do it, to both sides, or each term in this case, you're going to be okay. I got rid of the negatives and changed them to positive numbers. Or in other words, I multiplied everything by a negative 1. Okay, if you do it to one side and everything on one side, you got to do it to everything on the other side. And that's an equation, it's balanced. So you're good to go. So now I know what y equals, so I'm going to plug that in for this y next to this 3. So it equals 8x plus 6, just like it said over there. That's why I did that. I use the distributive property to get this. I combine my like terms to get this. Isolate the variable to get this. Just divide both sides by negative 22. Now that I know what x equals, I plug it into one of the problems, and I chose the first one. Looked a little bit easier. And then I isolate the variable, divide both sides by negative 1 in order to get y by itself. So I have my x and my y. For number 15, I just changed this one to see what x equals so that I can use substitution and plug that baby in for x. I solved for my x. That tells me what my x equals. So I put that in for x, and now I just have my y's. Now I'm just dealing with y's, and I can solve it. I use the distributive property, combine my like terms, I get this, and then I isolate the variable, I get y equals negative 1. I plug in that y value, that negative 1 for y, and I used it in the first problem. I could have used it in the second. You get the same answer. Does not matter which problem you put it in. So I work it out, and I get x plus 3 equals 16. Subtract 3 from both sides. X equals 13. Okay, one way you can go back and change all, or check all of these, is go back in and, you know, plug that 13 in for x, plug that -1 in for y. So, I mean, if you think about it, 13 minus 3 times a -1, that would change it 13 to, that would change it to 13 plus 3, that equals 16. That works. And then same thing here, 4x, let me see. If I were to plug in that 13, 4 times that, minus that, that would be a little bit weird. I may have to look at this one here. Let's see what's going on with this one. Good thing I'm going through checking it, because that's what happens. You know, I just checked the first one to see 13 plus 1. Yeah, that would work. This would not be, it would not equal, because that would be 13 times that plus 1. That would be a lot more. So let's see what's going on here. This is going to be x equals 3y plus 16. I added 3y to both sides, just checking it. And 4 times 3 is 12. 4 times, 4 times 16 is what I need. 4 times 16. I see my problem right off the bat. This should be 64. We'll just go right over that. Okay. All right. Now, I'm sorry, 4 times 6. This should be 64, because that was 16, right? Yeah, 64, sorry. This was still 20. This was still that, 16. This was still that 16. All right, let me just cross that off. That was still 16. Okay, so now I have 64, and then I have 11, and 64. Let me clear this. A negative 64, because I'm subtracting 64 from both sides, and a 9. Gives me negative 55. So negative 55 divided by 11 gives me negative 5. Negative 5. So if I were to put that negative 5 in here, this would be 15, and this would be just a 1. Just a regular old 1. Now let's plug this in. So I have 1 plus 15 would equal 16. Yes. 4 times 1 plus 5 would equal 9. That is better. So it's 1 negative 5. Good thing I checked that one. Else I was just rushing right on through. And you got an example of how to check it. See if you're right. Make sure if the x and y works in both of the equations. All right, sorry that's sloppy, but hopefully you listened and you know, it made sense. Good luck on the even ones.